and go. All right, so I'm gonna share my screen so we can start 2.3. All right, y'all, so 2.3 deals with finding domain and range. All right, so I'm gonna give us some definitions right off the bat. So I'll start with domain. So when we look at domain, what we're actually talking about is all the X values of our functions. So it's going to be the set of all X values. And often we call the domain the independent variable. So that makes the range will be the set of all Y values. And we often call it the dependent variable because to get your Y values, it depends on what X values we're putting in. So we call that the dependent variable. Okay, so we'll look at a few problems and then I'll get into finding the domain and range of a function. Okay. So I'm going to work an example. And what I think I'll do is I'm going to pull this up into homework problems so that we can see the graphs easier. So let me pull up my homework. All right, so y'all should be seeing my homework page. So what they gave me a graph over here with looks like 1, 2, 3, 4, 7 points on it. So for A, they want me to find f of -4. And y'all, I'm gonna pull my chat up so I can see. Okay. So when they want us to find f of -4, they want us to find the Y value that we get when our X value is -4. All right, y'all. So let's see. We would go to the graph, go left on the X-axis till we find -4, and then go straight up to that point. And I'm looking for the Y value that second point from the left is at. So if you look on that, that looks like that has a Y value of 5. So we would come down here to the blank and put in a 5. So are y'all good with that? Right there, what that is. All right. Then it asks us for our domain. So let me check that answer. It's going to make us go to the part B now. So the domain, and notice they already give us the set notation parentheses. So all we got to do is find the actual values. So remember, the domain is my set of X values. So I'm just going to look at my graph. The first point to the left, if I go straight down, has an X value of -5. My next one to it, the second point from the left has an X value of -4. So I'm just going to go through, separate these by commas. So I got -3, -2, -1. I got an x value of 0. And then the far right point has an x value of 1. So just go left to right, get all the x values, put them in, and then you'll check that answer. So part C is usually the tricky part of this. They want me to find any x values for which f of x equals 6. So what they're doing on part C, they're giving me the y value of 6, and they want to know if there's any x values that make that happen. And y'all, if you'll notice, the two top points of the V on each side are on the line where y equals 6. So since both of those are on the y equals 6 line, I need to get both of those x values. So my furthest point to the left has an x value of -5. So I'll come in and put my -5, comma, because I had one on the right side. Now the point on the right side that had a y value of 6, which is the furthest point to the right. If you look straight down, it has a y value of 1. So that's the only 2 points on that line. So we check that. And then it wants to know the range. So remember, the range is my y values. So usually on my range, I start on the bottom and work my way up. So the smallest y value where the V is, if you look at that line, that happens at the y value of 3. So we would put our 3 in, comma. I got points at the y value of 4. Now, although there's 2 dots on the 4, I only need to write it once, okay? There's also 2 on the y equals 5 line, so we got 5. And then finally got my last 2 points at a y value of 6. So notice, domain, we went across the x-axis and found all them points. The range, I'm mainly looking at that y-axis. All right, y'all, so then you would come in and check that answer. So the second one has the graph over here with a V-shaped line on it. So I'm going to zoom that in just a little bit so y'all can see it better. All right, so first off, they want us to find f of 3. So we want to find what y value corresponds to an x value of 3. So I'm going to go on my x-axis till I find 3. And once I find 3, I'm going to go straight up until I hit that line. So if you go over to 3 and straight up, when you hit that line, y'all, that looks like that has a y value of 3. So when x is 3, y is 3. So remember, when they give you a number inside the parentheses, that's your x value, okay? Now, the domain is going to be a little different. This has arrows on both ends of this line, which means it goes forever to the left towards negative infinity. It goes forever to the right towards positive infinity. When we got a line that goes both directions like this, we say that its domain is all real numbers. So different, when I had the points, I could individually pick them. But when I got lines like this, and they're heading both directions, we would go with E for all real numbers. All right, y'all, we would check that. So for what X values is f of X equal to? So remember, they're giving me the Y value of 2, and this time I got to find the X values. So we would go up to our Y axis, find 2, and go to the right and see what points are intersecting our line. So the first point that has a Y value of 2 looks like 4. So I would come down here, put in my 4. But if you notice, if you keep going to the right, the Y line of 2 intersects it again. And y'all, that looks like, what's that, an 8? So at 8, it also has a Y value of 2. So 2 points on that had a Y value of 2. Then we would check it. Now the range down here. The range is the Y values, remember. Now, I will not pick E on this one because the range is not all real numbers because both the arrows are going upward. They're not going down towards none of the negative Y values. So what you would do on this one, you would find the minimum Y value, which it's touching the X axis. So that means the minimum Y value is 0 and the arrows are heading up. So it looks like any value that is greater than or equal to 0 makes my range true. So y'all, you would come over here, since it's greater than 0, you would have to pick D. Because remember, it can equal 0 or be greater than 0. So the range always uses the greater than or equal or the less than and equal, okay? All right, so 0 was the minimum range value. So then you would check that and move on. So what I'm going to do, I'm going to do a similar exercise on this one so that y'all can sort of answer the questions. So it should change it up on us. All right, y'all. So for y'all's question number 1, I'm going to make this just a little larger for you. So for question 1, y'all, f of 2. What Y value do I get when X is 2? Oh, y'all are quick, so let me go. So if I go to 2, that takes me up to 4. So good job, Kara. Got that pretty quick. So that would be a 4. All right, y'all, how about my domain? So y'all going with A, B, C, D, or E? Ooh, so that's pretty good. Claire's on here with an E. So there you go. All real numbers because it points both directions. So the domain is all real numbers. So y'all, we would check that one. All right, so here's the tricky one. For what X values is f of X equal 1? So basically, for what X values do we have a Y value of 1? Ooh, let me catch up with y'all. Let me see. So if I go 1 on the Y axis, I get a 5 and a 7. So good job. When X is 5 and 7, we get a Y value of 1. And then y'all, I'm going to tell y'all a trick. If you notice, all these examples, the V is touching the X axis. So our range is going to be pretty much the same on all of these. So what y'all going? A, B, C, D, or E? So D, and you're putting in a 0. Oh, you're so close. So close. A and 0. There you go. Because remember, it's got to have that equals on it also. Okay, Kara? So you always want to choose the greater than or equal. And then y'all said put in a 0. and then we would check that. All right, y'all, so I'm gonna go back to the tabs and get more notes. So that question was really designed to show y'all graphically how to see these. But what we're about to get into is what we call finding the domain of a function. So when we're given a function, our domain has to consist of X values that I can put into the function for the X's and get a real number out of it. So when we're looking at functions, there's two things we're worried about, and we're only going to worry about one of them right now. Later in life, after about 3 or 4 weeks, we'll look at the other situation. But when we're looking at a domain, we're only worried about excluding numbers from the domain when we have fractions. Okay, because remember, a fraction, the denominator of a fraction cannot equal 0. So remember, if it does equal 0, that makes it undefined. And undefined is not a real number. So what we do for our steps. First thing I look at, is the function a fraction? If no, then the domain is all real numbers. If yes, so if you do have a fraction, what you're going to do, we need to figure out what number makes it equal 0 in that denominator. So we're only going to set the denominator equal to 0. Y'all, once I set that denominator equal to 0, I'm going to solve for the variable. Once I have this all solved and got that variable solution, I'm going to then exclude any solutions from the domain. And we use set builder notation for the answer of the domain. All right, so I'm gonna pull my camera down just a little bit. So what we do, set builder notation, we have the set parentheses. We list the variable. So this is list the variable. Then it has the bar. The bar means such that. And then you tell the conditions. X is a real number. Now, if you don't have a fraction, you would be done there. X is a real number. But if you do have a fraction with the variable in the denominator, then we'll have X is a real number and X is not equal to whatever number we get. So you list the variable such that, and then you list the conditions. So this is the conditions. So before I do the problems they got, I'm going to do one with you. Just an example here. So say I'm given f of x equals, oh, let's say 3 over x. Now I'm going to tell you a trick. Since the x don't have an exponent, you would treat it like a 1. So the highest exponent in the denominator usually tells me how many numbers I got to exclude from my domain. So since this is an x with the 1, that means there's only one number that'll make this undefined. So we have our fraction. So remember, we got to set the denominator equal to 0. Well, this one I picked is pretty quick. It's already solved for x when I put that down there. So that means if you put a 0 up here, 3 divided by 0 would make that undefined. And undefined is not a real number. So for my domain, the only number I'm kicking out, so I would have x such that x is a real number and x cannot equal 0. Okay, so they'll have probably most of this, and you just gotta pick the one that's got the not equals, put your 0, okay? All right, so y'all, I'm gonna let y'all help me on this one. So here we go. We got an f of x equals 13 over x minus 3. So I'm gonna give y'all a minute or two to play with that and see if we got any numbers we need to exclude on this one. So y'all on this one, do I need to exclude any numbers from this? All right, so let me help y'all out. So first thing, we know we're going to have to exclude numbers because we do have a fraction here. So since I got a fraction here, so this is a fraction. So since that's a fraction, we're going to take our denominator, set it equal to 0. So we're going to set x minus 3 equal to 0. So we got one step to solve that. We're going to add 3 to both sides so I can get that x by itself. So I'm going to come in here and add 3. So that's going to make the x by itself on the left side. 0 plus 3 gives me 3 on the right side. So this is telling me if I put a 3 in here, I'll have 13 divided by 0, which is undefined. So we must exclude the 3. So I'm going to come in, put my set notation. My variable was x, such that x is a real number and x cannot equal 3. All right, y'all. F of x equals 3x plus 7. So first thing, do we have a fraction? So good job. There's no fraction. So y'all remember, we said, well, go, if there wasn't no fraction, then my domain is going to be all real numbers. So we don't have a fraction, so we would automatically pick x such that x is a real number. And y'all, I don't care what this is. If it's not a fraction, we got to pick that. If it is a fraction, then we're going to have something we got to exclude. So here we go. We'll get y'all going now. Oh, what if I had a 21 over 7 minus x? So any numbers I need to exclude from this domain. Yeah, because that's 7 minus x on the bottom, right? Because we do have a fraction. So since we got a fraction, we're going to have to set that 7 minus x equal to 0. And then that'll give me one specific number that I must kick out. All right, so y'all solving that. Y'all, there's two ways to solve this. One way is to subtract 7 from both sides. So you could come in and subtract 7. And you'll have negative x equals negative 7. And remember, the x can't be negative, so we would come in and divide both sides by negative 1. Well, all these negatives are canceling and make that a positive x equal to a positive 7. So if I put a 7 in for that x, 7 minus 7 makes that 0, which makes it undefined. So we have to exclude the 7 from the domain. All right, so remember we would get our set notation. Our variable is x such that x is a real number. And x cannot equal a positive 7. So any other number I put in there, I'll have an answer in the bottom, and then 21 divided by that will give me a real number. Now, it might be a fraction or a decimal, but it'll still be a real number. So remember, the only numbers that are not real are undefined and imaginary numbers, okay? And we'll see the imaginary stuff later. All right, y'all, this one's on y'all. F of x equals 3x plus 4. So any numbers we need to exclude from this domain. I keep getting Amber alerts on my phone. So y'all excluding any numbers from that domain? No, good job. There's not a fraction there, so no fraction. Means this works for all real numbers. So you're going to come in here, x such that x is a real number. All right, so let's turn the heat up. Let's do a P of X. P of X equals X squared plus 9. Are y'all excluding any numbers from this domain? Our little gunshot today. So you got to know with a question mark, but that's good because it is a no, because guess what? There's no fraction. No matter what number I put in for the X, I can square it and then add 9. So since I don't have a fraction, once again, this will work for all real numbers. So really, these don't have work unless you do have that fraction, okay? All right, I got another, what's it? G of X is going to equal 2 over 7 minus 8x. So guess what? We do have a fraction. So since I have a fraction, I'm going to set the denominator only equal to 0. All right, so let's solve this. So we're going to subtract 7 and move it over. That'll give me the negative 8x equal to negative 7. Divide both sides by negative 8. And y'all, once again, all these negatives are canceling, making this a positive. And I can't do nothing with that, so I'm going to leave that as a positive 7/8. So here we go. We'll have our set notation. X such that X is real and X cannot equal 7/8. But guess what? Although it can equal 7/8, it can be infinitely many more numbers, okay? That number line goes forever in each direction. All right, y'all, here y'all go. Y'all get to do this one. P of X equals absolute value of X minus 5. So will I exclude any numbers from this domain? So let's see, Michaela, Raven, Leona. So no is the answer because guess what? No fractions. So although we got absolute value, any number can go into that, okay? So this will be what? X such that X is a real number. So y'all, that's what they're going to do. This is mainly the gist of this homework. When you get to the functions, if it does not have a fraction, it's going to be a domain of all real numbers. If it is a fraction, then take that denominator, set it equal to 0, and find those values. All right, so let me fix my paper. All right, so this is just a review here. Because we got 2.4 coming up. So since I had extra time, I wanted to do a little review with y'all. So y'all, if I had an X plus 2 times the X plus 5, have y'all ever heard of FOIL? And yeah, so FOIL is just a way to remember that when you're multiplying binomials like this, it's sort of a way to let you know that you got to multiply 4 times on that. So basically, it's a fancy distributive property. But I'll show you how to get the FOIL. So the FOIL, the F, means the first ones from each parenthesis. So the first ones in each parenthesis is the X. So remember, that's like an X to the first times the X to the first. When you multiply variables, add those exponents. So X to the first times X to the first, 1 plus 1 will give me an X squared. The O means the outermost terms. So the outermost would be that X and that 5. So you multiply the X times a 5, well, that would just give you a 5X. So basically, all we did was take the X, distribute it through the second parentheses. So y'all, the I stands for the innermost terms. The two innermost terms are the 2 times X. So y'all, 2 times X will give us a 2X. Which leaves me with the L. And the L is the last term in each parenthesis. The last one in the first parenthesis is 2 times the last one in the second parenthesis is a 5. So that 2 times 5 would give me a 10. So they just want you to remember you got 4 things to multiply. But y'all, all I did was take the X, distribute it, take the 2, distribute it. So here's a question. Can this go further? Can I simplify this answer any further? Oh, I'm getting a lot of yeses. Okay, so y'all must realize I got like terms in the middle, right? So since I got like terms in the middle, I'm going to add them. Now here's the trick. We can only change variables the way they look when we're multiplying. Like we change these 2 X's into an X squared when we multiply. But when we add, we cannot change the X's when you add. Okay. So that means this X squared comes down. The 5X's plus the 2X's just gives me 7X's. And then bring down your 10. So that right there, final answer. So just bring back a few memories, right? So y'all, let me do one with one positive and one negative. So these, I call these conjugate pairs. And you'll see stuff happen when you multiply conjugate pairs like this. So conjugate pairs always got the same number. The only difference is the operation. One's being added, one's being subtracted. But anytime you multiply conjugate pairs, you're going to cancel out some of the terms, okay? So here we go. Distribute our X. X times X is an X squared. X times -7 is a -7X. Then the 7 here times X gives me a positive 7X. And then that positive 7 times -7 gives me a -49. So y'all, what is happening to this one? So what I'm looking at is my middle. So since one of them is a -7X, one of them is a positive 7X, these are going to cancel out. There you go. Perfect. So that all we get is what, our X squared, and then bring down our -49. Now I think y'all are answering these quicker, but I think our school, our internet's a little messed up, so I'm on my hotspot. So I think it's lagging just a little bit on me. All right, next I'm going to do this. X plus 5 squared. Y'all, the biggest mistake I get, this does not equal x squared plus 25. Some people just want to shoot those exponents in there. You can do that if all this was being multiplied, but since it's being added, this is the binomial squared. Anytime you got a binomial like this, which is two terms and squared, you gotta come in and write this twice. Okay, there you go. All right, now McKenna, we got it rolled x plus 5, x plus 5. We're going to FOIL it. So here we go. X times x is an x squared. X times the 5 is a 5x. In the middle, 5 times x is 5x. And then the last one, 5 times 5 is 25. Oh, good. You already got that. Kara done got me. X squared plus 10x. Because all I could do is add my like terms. And that was good, Kara, because a lot of people, they'll see these 5s and they'll want to cancel that. But remember, these are both positive. So do like you did, add them together, and then bring down that 25. All right, so that's a little foiling I wanted to do. So I'm going to hit y'all up with a little bit extra right here. All right, so I got 2x squared plus 3x minus 4 minus a negative x squared plus 7x plus 8. So this was a little bit of the 2.2 support to get you ready for this section. And the trick is any parenthesis that follows subtraction, you got to distribute that subtraction through the whole parentheses. So nothing in front of the first parentheses. And this has to be done before you can start trying to add these, okay? Because if you add them like they look, the signs might be bad. So drop your parentheses when you're subtracting. So the first parentheses come out the same. 2x squared plus 3x minus 4. But y'all, what's going to happen now, I'm subtracting a negative. Well, remember, two negatives will make that a positive x squared. Distribute the subtraction to the 7x will make that a negative 7x. Distribute the subtraction to the 8, and that'll make that a negative 8. I sort of distribute that subtraction like a negative 1, and I'm basically just multiplying everybody by negative 1, which all that subtraction is doing is changing the signs of the things in the parentheses. Now that you got the parentheses gone, we can now add like terms. So the 2x squared and 1x squared will give me 3x squared. Oh, I think y'all got this. So let's see. Do we get negative 4x? Yeah, because 3x minus 7 gives me negative 4x. Negative 4 minus 8 is definitely a negative 12. Oh, good job. Alrighty, so let me play with y'all for about 5 more minutes and then we'll be done. So let me go over some exponent rules. Now, we won't be using this right off the bat, but you will eventually. So exponent stuff. How about this? Any number to the 0 power. Any number to the 0 power, what does that equal? Oh, Taylor and Lana. So I will say this, out of the 3 chats, out of the 4 chats, 3 are wrong. So there you go. Y'all, anything to the 0 power is 1. And y'all watch this. I'm gonna pull my calculator up. So on my calculator, I'm gonna do 7. And I'm gonna use the upside down V caret key under the clear button. And I'm gonna put in a 0. And 7 to the 0 equals 1. I'm gonna put in 12 exponent 0. 12 exponent 0 gives me a 1. Now remember, for negative numbers, I would put them in parentheses. So -9 in parentheses to an exponent of 0 is going to equal 1. Okay, so anything to the 0 power is going to equal 1 for us, okay? Y'all, what about this? What if I had x to the 10 divided by x to the 7? What would that equal? X to the 3rd. Boy, that's quick. Because remember, when we multiplied earlier, we added exponents. When you divide, subtract exponents. So 10 minus 7 left me with 3 x's, okay? All right, y'all, so I don't really have any more. So do y'all have any questions? So I sort of keep it mellow this first week or two because we usually have a holiday. And then we've had new students coming and going. So I just try to keep it mellow. So y'all remember, we'll have class Wednesday. Next Monday, we will not have class because it is Labor Day, okay? So we'll have class this Wednesday, and then I won't see y'all again until the next Wednesday. So let me see. All righty, so I see no questions. Anybody needing support work? So I'm getting a no. All right, so this is pretty light, mellow, and there's not even a support lesson for 2.3. So you'll be able to go straight in, knock out your 2.3 college algebra, and then it's only 8 questions and be done, okay? All right, y'all, so what I'm gonna do, I'm gonna take my video, I'm gonna upload it to